Hi, my name is Samir Desai, and in this video, I'm going to teach you how to rank the stability of conformational isomers with Newman projections.
Some conformational isomers are more likely to occur than others due to strain. To quickly review the last lesson, conformational isomers, or conformers, are molecules with the same connectivity but differ in the arrangement of the elements. Each molecule has a varying amount of strain that impacts the stability of the isomer. We know that electrons are negative, and so they repel each other. This has important applications all over the place in chemistry, and when we're talking about the electrons in one bond repelling the electrons in another, we call that torsional strain. When a molecule is able to rotate around a sigma bond, there will be varying amounts of torsional strain dependent on the substituents relative to one another. We'll use the terms like anti and eclipse to describe torsional strain. Steric strain, similar to torsional strain, is also created through repulsion. Bulky substituents have big electron clouds that want to avoid being near each other, so steric strain is created when these substituents are pushed near one another. We'll use terms like gauche and totally eclipsed to describe steric strain. Systems with high energy aren't stable. Like a ball sitting at the top of the hill or a stretched rubber band, they will change to find a more stable position. The same is true of molecules. They have their highest stability when they have their least strain, and will tend to rearrange to find those positions. Ultimately, the most stable conformer will minimize torsional and steric strain, and thus be the lowest energy conformation and the most likely to occur. The best way to grasp the distinction between torsional and steric strain is through Newman projections. Anti indicates the substituents are the furthest apart. Since they are the furthest apart, this creates the least strain and the most stable conformation. Totally eclipsed creates the most strain and therefore is the least stable conformation. From least stable to most stable, totally eclipsed, eclipsed, gauche, anti. Let's take a look at conformational isomers and rank these Newman projections by stability. Order the following conformers from most stable to least stable. Notice that A and G are identical molecules, but as we progress from molecule to molecule along the way, these conformational isomers are being rotated 60 degrees at a time around a central single bond. By the time we've reached G, the molecule is rotated a full 360 degrees, which is why it's the exact same conformation we see in A. As discussed on the previous slide, anti is the most stable conformation, while totally eclipsed would be the least stable. The most stable conformations will minimize strain. The way to prevent torsional strain is to prevent any groups from overlapping. As we can see, A, C, E, and G are not overlapping, so we don't have any torsional strain. This is in contrast to B, D, and F, which are eclipsed and less stable in comparison. So we know A, C, E, and G are stable, but some of these are more stable than the others. The conformations experiencing steric strain will be less stable. We want the substituents, in this case bromine, to be as far away as possible to ensure there is no interaction and no strain created. A and G have no overlapping groups, and the bromine substituents are as far as possible from each other. These conformations, called anti, are therefore tied as the two most stable conformations. C and E don't have any torsional strain because we don't see any overlap, but the bromines being so close create a steric strain that leads to some instability. These are known as gauche and slightly less stable than the anti-conformations seen in A and G. B, D, and F are the least stable, but again, the stability is on a spectrum. Notice that D not only has overlapping groups, but the two largest groups are the ones overlapping. This is the least stable of the set and are called totally eclipsed. B and F are slightly more stable because the largest groups are not directly overlapping. While it may be less stable than the Newman projections without any overlap, it's certainly more stable than D. This is called eclipsed. Let's plot the expected energies of each of the conformers to help see the relation between stability and energy. The trend between stability and energy of a system is one of the most misunderstood things in science, but the connection we saw earlier is straightforward. Conformations experiencing torsional or steric strain are dealing with the repulsive forces, which increase the potential energy of the molecule. Higher energy conformers will be less stable, while lower energy conformers will be more stable. Therefore, the anti-conformation, not having to deal with torsional or steric strain, will be the most stable molecule and have the lowest energy. Totally eclipsed is the least stable and has the highest energy, because it has the two largest groups overlapping each other. Gauche and eclipse are intermediate. Eclipse will be slightly higher energy though, since it has some overlapping groups, whereas gauche does not have any groups overlapping. So we should see anti having the lowest energy, a spike in energy for the eclipse conformation, a slight decrease in energy with gauche, and then a rise again with totally eclipsed conformations. Understand the stability of conformational isomers and being able to rank these Newman projections is frequently occurring topic in organic chemistry, so hopefully this lesson clarifies the concept.